Hello, and welcome to another episode of NASA Science Live. I'm your host, Jacob Richmond. This past Monday, September 27th, the Landsat 9 satellite launched from Vandenberg Space Force Base in California. It was the latest in a legendary legacy of satellites that have been monitoring and tracking changes across Earth's landscapes for nearly 50 years. The mission is a joint effort between NASA and the US Geological Survey, and it has provided the longest running satellite data record of our changing planet. Landsat satellites allow us to measure how the Earth is changing over time. With Landsat 9 joining Landsat 8 in space, they'll each be circling the globe every 99 minutes, and together will collect images of nearly the entire Earth every 8 days. That constant source of high quality data will help to answer the many questions we have about Earth's changing climate, urban sprawl, and even our very own food supply. Landsat data is also free and open to anyone, which means decision makers from around the world can use it to better monitor land use changes, manage agricultural practices, allocate scarce water resources, respond to environmental disasters, and much more. And I'm very happy to tell you all that we have some very accomplished earth science researchers joining our show today, and they'll answer some of my questions. And a little later, we'll be taking questions from our viewers as well. So, starting now, you can submit your questions using hashtag Landsat on social, or just drop your question in the comment box wherever you're watching this. First, let's learn a little bit more about that legendary legacy of Landsat.
The blue marble. That was our first view of ourselves. We really are the blue planet. We're hanging out here in the middle of nowhere. In fact, Apollo imagery was part of the justification for putting together a satellite that would look at the Earth.
That satellite was the first Landsat. The Landsat mission now holds the title for the longest continuous space-based record of Earth's land in existence. At least one Landsat satellite has been orbiting the Earth since 1972. That's nearly 50 years of steadfast observation. The program was born in the midst of several historical flashpoints during a time when the world was changing quickly. But the Landsat story doesn't actually start with NASA. It starts with the United States Geological Survey. But let's pause for a second. Obviously, there was a big push to make an Earth-observing satellite. But what exactly did it need to do? Landsat's entire job is to collect light, visible light like this, and non-visible light like this. After Landsat captures the light it sees, it can make two kinds of pictures: true color images and false color images. Did you know your eyes can only detect red, green, and blue? It sounds crazy, but it's true. In fact, if you took a magnifying glass to the screen you're probably looking at right now, you'd see a jumble of red, green, and blue dots. Mix those colors together with different intensities, and your brain interprets all the colors of the rainbow. True color images are made by combining red, blue, and green light. But what's even more amazing? Landsat also captures infrared light beyond what we can see. And that light can reveal some incredible things when you look at a false color image, like the difference between types of plants, how healthy those plants are, healthy coral reefs and even dead coral reefs, fire tracking, ocean pollution. The possibilities are nearly endless. The true test came when Landsat 1 launched on July 23, 1972. But with this launch, the United States and soon the world would step into a new paradigm of Earth observation. Never-before-seen snapshot of land resources in the environment would be key for critical decision-making decades into the future.
We are now joined by NASA Research Assistant Nikki Tooley. Nikki, thank you so much for being with us today.
Thank you. Thank you for having me, and I appreciate being here today.
Of course. So, Nikki, as you may know, I recently heard your story and your background and how you got started in this research. And so I definitely need you to tell our viewers about that. So if you could give us a little bit of that background and specifically how Landsat was involved in a very memorable moment of your life.
Sure, thank you. So, the story that you just heard that was shared with you was as a result of the USGS Human Dimensions and Ladies of Landsat collaboration. And in that story, you heard that I'm a member of the Navajo Nation, which is one of over 500 Native American tribes located in the United States. And in that story, it further shares some background of who I am and where I come from. And one of the things you'll learn is that one of the first homes that I grew up in didn't have running water. And so we had to haul water from local watering points to support our livelihood. And I believe that it is from that point that I began to get an interest in water science. And so growing up, I was surrounded in this area by family, and we spoke a particular language, which was the Navajo language. And so when I went to college in the pursuit of an academic career, that is one thing that came as a huge shock, was culture shock, leaving a landscape that I knew and the people that I knew and was surrounded by. And so luckily for me, when I took a remote sensing class, I learned about Landsat and what the data provides. And so that comes in the area of Earth observation, satellite imagery. And so within that way, I use Landsat to remind me of home, to be able to look at the landscape that I grew up on and to not feel so homesick and to feel a way of having a connection to home. And in many ways, working with the NASA WAYO DSET project and the current role that I'm in, I feel that that again has brought me away back home again. And in reality, Landsat helps us have that relation to home as we all live on planet Earth and Earth is our home.
Ain't that the truth? So you mentioned a couple of terms. I've been hearing a lot of those terms lately here working in NASA Earth Science, especially during the summer months when we've had heat waves and droughts. So you mentioned WAYO and you also
Yeah.
mentioned DSET. I know you know a lot about both of those, but our audience may not. Very important terms those are. So can you please explain what those mean? And then please, specifically just how has the Navajo Nation Drought Project helped that community where you grew up?
Yeah, so at the time I joined the team, I joined the team to help in these capacity building efforts to look at DSET, which is the Drought Severity Evaluation Tool, which at the time was funded by NASA WAYO, the Western Water Applications Office. And so this project was co-developed with the Desert Research Institute and the Navajo Nation Department of Water Resources. So DSET uses remote sensing that is modeled with in situ data that is all combined into this web interface that you see here on the screen that was really designed to be user-friendly to meet the unique challenges of water management on the Navajo Nation. So what does that all mean? What DSET does is it uses satellite imagery to tell a story through the light of the landscape. And so Landsat is one of these satellite databases that is used with other data that is collected and verified. The Department of Water Resources has contributed some ground-based data to where we can look at these interactions between the data we see coming from the satellites and the data we see coming from the ground, to be able to use these drought monitoring efforts, looking at precipitation, looking at snow, ultimately looking at the impact of drought on the landscapes through these drought conditions to further analyze crop analysis, surface water, and also to be able to look at the snowpack state. So overall, looking at the impact on the water cycle.
You mentioned crops, and I know you probably know more than most this phrase "water is life," right?
Mm-hmm.
And obviously on that list of what we need to survive is food, and there's a very, direct correlation and relationship between water supply, food supply. What can you tell us about how Landsat and other NASA satellites are involved in monitoring that food supply?
Sure, I totally agree with you in that statement, water is life. In my language, we say tua'einat. And in thousands of other ways, we can definitely translate that statement because it is true that across the globe, the importance of water and food will remain a constant issue of great importance that we're all familiar with. I just shared with you some ways that satellite data is being used in a particular way to look at the impacts of the water cycle. We need water to grow vegetation, and oftentimes that vegetation is to grow food. When our water resources are impacted, that impacts our food production, which can ultimately impact food security. Drought is one of those major events to continue to monitor. Earth is a big place. However, we need to understand that as one planet, we're all connected. So how does NASA satellite data help us to track and monitor our food and what we drink? So just think about the last time you went to the grocery store and you've seen that beautiful display of produce, and oftentimes the water is missing there. Do we ever give a moment to think about what it took to get that piece of fruit or vegetable to our hands to enjoy it? If not, that's okay, but millions of others in different ways have thought about that question in different ways to use satellite data to be able to monitor that, to ensure that we have that food or that bottle of water available to us to consume. And so that's what satellite data helps us to do. The satellite data continuously collects these images to tell the story that we're interested in of what's happening on the landscape, what's impacting our crops, and what are the state that the production of crops are in. Satellite data, for example, can help us to understand soil moisture, which is a really big area of how much water is in the soil and how might that impact the crop production. Satellite data also helps us to look at irrigation, crop yield, crop production, productivity, and many other soil and crop characteristics that go into getting that seed that is planted in the earth to food on our table.
Thank you. I mean, normally when that mister comes out on the produce aisle, my first reaction is to get out of the way. But now I have a totally different thought that I'll take with me every time I'm in the grocery store. Thank you for that. And thank you
Most
for joining
definitely.
us, Nikki. We will be back with you, Nikki, a little bit later to answer some of our viewer questions. And again, get those in right now if you want to using hashtag Landsat. And as we can see, the data we receive from Landsat and lots of other satellites really are important to our everyday lives, even down to how we source our food. So, with that in mind, how about we head right to the kitchen and see how NASA data is being served up?
My name's Jocelyn Argueta.
I'm your host, Kathleen Gata.
And this is Snack Time with NASA. So we can send a rover to Mars, but now the question is, can we make a tasty dip?
And this is my dog, Bowie, and we both really love cheese. I will eat a space potato in my lifetime, I promise you that.
Because it's my first time and I'm not sure how it's gonna taste.
It's so bad.
Did you know that NASA plays a big part in the food you eat? We use data from space to monitor agriculture and track food security. So coincidentally, we have some of the crops that we keep an eye on. Can you tell us a little bit about why NASA studies agriculture in the first place when we're known more for space exploration than cooking?
As we all know, our planet Earth is also a planet, and so NASA has satellites that are pointing out into space, but it also has a lot of Earth observing satellites pointing here down at Earth. And of course that's really critical because we live here, and that's important for us to track and understand how we're changing our planet, how our planet is responding, and in particular tracking agriculture, which is what we're concerned with here. Food security and agriculture are one of the biggest challenges we face in this century. And NASA's satellite data, since actually going back to early days of satellite monitoring, there has always been a large focus on agriculture. Agriculture covers a huge part of our land system. And what that does is that helps us to get an accurate and a timely understanding of potential shortfalls or surplus of crops and food production around the world.
So I have edamame in front of me, and what I believe to be the most underrated part of a cheese board, which are carrots and olives.
Yeah, those are pretty water-intensive crops, and they're grown in the Central Valley, which is someplace where proper water management is really critical. I see you have some grapes there too. Speaking of grapes, NASA has an ongoing project with the U.S. Department of Agriculture and Vintners in California called GrapeX, where we're using data from Landsat satellite along with multiple other space and ground-based observation sources and advanced computer models to help to schedule irrigation for these vineyards and therefore preserve the precious resource water. It's really precious in California.
Well, it seems to me that instruments on board the ISS are pretty crucial when it comes to monitoring our human-caused climate change. Climate change is bad.
Yes, and the really great thing about EcoStress is that it complements these other instruments and other satellites like Landsat to create a continuous long-term record of the Earth system. And right now, NASA is working on future missions that will build on these records to provide climate scientists a holistic view of the Earth. And this provides us really unique insights to how vegetation and forests around the world are reacting to environmental and climate stressors.
Keeping an eye on our food sources is just one of the many applications of Landsat data. There's another big one that we've all heard about, especially in the summertime months as well, and that is helping scientists monitor wildfires and their effects across our planet. To tackle that topic, I'll now welcome in Dr. Liz Hoy, a senior scientist at NASA's Goddard Space Flight Center. Liz, thank you so much for being on the show.
Thanks for having me.
Our pleasure. And first, just like I did with Nikki, I'm told you have a memorable moment from early in your career that involves fires and Landsat. Could you share that with us?
Yeah, well, Nikki's story was incredible to hear, and I so appreciate that she shared it with us. I started using Landsat imagery to look at forest fires back as an undergraduate in college. And then as a graduate student, I actually got to go to Alaska, and there are these cold northern forests there that can really burn during wildfires. And I would dig in the soil and try to understand how much carbon is released from these fires. And then as a PhD student, I actually had the opportunity to take my infant son with me to Alaska. My husband came, he took his paternity leave, and the three of us traveled around and camped, and I took measurements of this soil layer that burned, and I would compare it with Landsat imagery. So it was an incredible experience for us, but it was daunting for us as parents.
I know, I was just going to say, when I first had our infant, I also wanted to go to Alaska and document wildfires, but actually, that's not true. We were surviving. But thank you for your work there. One thing I also learned from just working here in Earth science at NASA is that fires aren't just sort of an acute thing that pop up every once in a while in certain areas. They are constantly happening around the world, a lot of them. So could you just take a second and describe the global phenomenon of fires in a way that helps people like me understand the scope and scale of them?
Yeah, sure. Wildfire is a natural occurrence across the landscape. And we have, I think in the worldwide, about the area of the size of the European Union burns every year. So it's an incredible amount of fire. Fire clears underbrush, fire helps new seeds to grow, and fire also just helps to keep forests in their natural cycles of growth. What we use this Landsat imagery for is we can see where fires are burning, what their frequency is, how severe they are, how intense these fires are, and it can really help us to have a big picture of this fire and where it is in the landscape.
I mean, we also know there are lots of satellites up in space doing lots of different measurements. Many of them are involved in fire research in some form or fashion, but can you describe how Landsat works in harmony with those other satellites up there as well to understand fires?
Sure, yeah. So Landsat 9 now up there, that's going to give us, along with Landsat 8, a view every 8 days of where fires are on the landscape. And when we take into account other satellite imagery as well from comparable satellites, we're having a view every 2 to 3 days. So with this 50-year record that we already have, we're getting an incredible amount of data in. I like to think about a family photo album. So if you have a picture of someone as a baby, and then you're able to watch them grow until they're a 50-year-old adult, you're really seeing how they're changing over time. And we're seeing that with this Landsat imagery now too. Having this record really helps us to look at all these different aspects of wildfire and really better understand how it's impacting the landscape, and then how fire and resource managers can take that imagery and use it to better allocate resources where there might be a really severe or intense wildfire.
I know some of us tend to think of fires also as an effect of the hotter, drier climate as that's intensifying, but there's another aspect of that I think we should know more about, and that's the effects from fires. So what can Landsat and other NASA data teach us about the after fire consequences of fires on Earth, whether that's on the land or in the atmosphere?
Sure, yeah. So Landsat imagery, as well as other satellite products from NASA and others, they are really useful in understanding how wildfire is impacting the land and the atmosphere. So I'll start with the atmosphere. And when a fire burns, it's releasing a lot of carbon into the atmosphere. Those emissions and that smoke, it's all going into the atmosphere. That can actually cause the atmosphere to warm, which can actually create conditions for more fire down the road. So that's one thing. Then the second thing is that these emissions, the smoke, can be really harmful for human health. So when we think about it, we have to think about where is the smoke and how are people going to be impacted? Are we going to have more people in the emergency room with respiratory issues? This smoke can also travel thousands of miles. And so there are other examples. For example, in the Canadian wildfires the smoke from those fires have actually traveled all the way over to Greenland and have been deposited on the ice sheets there. And it's resulted in more melting of the ice sheets because that soot warms up more than the ice would normally. But then I also want to point out that there are really important impacts on the land as well. And so this is some of the work I do comes in. And so we're looking at how forest fires across the landscape, how those areas recover after a fire. And we can see where there might be the potential for erosion or for landslides. And so we're looking at how the land recovers from a fire, what vegetation is coming back, where might there be a risk. And then we can give that information to land managers, fire managers, natural resource managers to help them to understand where they might need to allocate resources for restoration.
Liz, thank you so much. Those are all very fascinating answers about something that's terrible and fascinating all at the same time. So thanks for your work. And please don't go anywhere. It's now time to take some questions from our viewers. So if you're just tuning in, remember, you can still have your questions answered live right here. Just use hashtag Landsat on social or the comment box from wherever you are watching. And since many of you are already watching on social, I wanted to mention one other thing that the whole Landsat team is enjoying as we speak, which is hashtag LandsatCraft. So if you don't have a question, but you want to help us communicate about the mission, here's what to do. Go to the Landsat image gallery. You can search that up. It's easy to find online. There's tons of great images. Scroll until you find an image that inspires you. Then create something artistic or crafty based on that image. Take a photo or two, share it with us on social media using that hashtag LandsatCraft. And if you don't do art, but you like to look at art, go check out the hashtag anyway. We've already gotten a lot of amazing creative contributions. All right. Now let's bring back Nikki and Liz to answer those questions. And again, thank you both for staying with us. Our first question is from James on Facebook. He asks, how are you working with USGS to better understand hazards? So Liz, I'll kick that one over to you.
Sure. So it's a combination of NASA and USGS that really put these Landsat satellites up into orbit. And so we're getting a lot of our imagery actually through USGS channels. But USGS and NASA work together to make some burn severity products that we use to really understand what's happening after a fire burns or how severe it burned, and then trying to understand what's going to happen in that region after a fire. So it's really a combination between both of those agencies.
Thank you. Tim on Facebook asks, and this will be for you, Nikki. He says, while you no doubt see much land becoming unusable, are there areas that are improving?
Yeah, so I think that question can go back to looking at the human impacts, but also the nature impacts, just to speak to what Liz shared with us. And so I really find it interesting that there's this opportunity that satellite imagery provides us, for example, that was just discussed with wildfire, how we can monitor the impacts that wildfire has on the landscapes, whether they're connected to agriculture lands or to places that are of more open areas. But with that imagery, we're able to see the revegetation that comes back from the wildfires. And then, as was mentioned, we're also able to put input into looking at how we might help with erosion that comes with the wildfires that impact a watershed, or we're able to look at how we might help the vegetation come back to some of the natural state that it was at before. And I think those are two ways together, in which the natural cycle and the human impact can come together in helping those landscapes.
For sure. And this next question I want you both to answer, but we'll start with you, Liz. Elda Pena, also on Facebook, asks, what surprises have these Landsat observations given you?
Surprises. Well, I'm always surprised when we're able to figure out what we're looking at and understand it in a new way. I'm surprised when I learn about how severely burned certain areas are. Sometimes, it's hard to really see it. And what we can do with this Landsat imagery is we can look at an entire area. Sometimes it's remote locations, we can't always get there, but when we can use the Landsat imagery, we can really look at these larger areas. And on regional scales, it's just incredible how much fire there can be in certain areas.
Absolutely, I can imagine. All right, we have a question from Mordecai on Twitter. And the question is, how long is commissioning, calibration, and validation before people can start using Landsat 9 data? So I'll take that one a little bit. We also have a question right after that from Tui Mising on Facebook, which is a similar question about where will Landsat 9 images be available? So the shortish answer to those questions is that the data is managed by the US Geological Survey. That's why it's a partner mission. So that typically happens at 100 days after launch. So realistically, when that data has become open and available for the public and researchers and everyone to use, that'll be probably early January after the holidays, but that's just a little bit after that 100-day mark. And you can just head over to the USGS archive and find those at that point. All right, Linda on Facebook asks, how long will the satellite last? So Liz, I know you've been, studying remote sensing for a long time with data from a lot of different satellites, and they're all a little bit different, but do your best and predict how long the NASA Landsat 9 satellite will last for us.
Well, one thing that's been really great about the Landsat program is that some of the satellites have actually outlived their expected lifespan. So as we said in that video in the beginning, we've had a satellite that's been up there, at least one of these satellites, for almost 50 years. And so I hope Landsat 9, exceeds its design life and stays up there for many years. And then we keep going with this program, because having this long-term look really helps us to understand how the Earth is changing.
Absolutely. Well, that is about all the time we have. Liz and Nikki, thank you again so much for joining us today. It's been a privilege to talk with you.
Yeah, thank you for this opportunity.
Thanks so much for having us.
And thanks to all of you, our viewers, for joining us online. Like we mentioned before, Landsat 9 launched on Monday from Vandenberg Space Force Base, and it is now continuing the nearly 50-year legacy of this amazing, legendary Earth-observing satellite program. You can stay up to date on how NASA studies our home planet all the time by following @NASA Earth on Facebook, Twitter, and Instagram. And if you want to learn more about all things Landsat, we just recently released a really cool interactive website. So go check that out at nasa.gov/Landsat9. Again, I'm Jacob Richmond, and it's been an honor to be your host for NASA Science Live. We hope to see you at the next one.